Assalamu alaikum. I'm your host Muhammad Shiraz. Welcome to the 15th program of Computer Programming Concepts. Dear students, in earlier programs we discussed about user-defined functions. We studied that a user-defined function is implemented in 3 steps. First, user-defined function is declared. Declaration of the function is composed of the return type of the function, name of the function, and parameter list required for the function. Then we define user-defined function. Definition of the function is composed of the actual logic or the purpose of the function. Then, whenever functionality of the function is required, we just call the function and function provides us the required functionality. We also studied that a function can be called many times. We also discussed that a function can be called from any other function. In our today's program, we will extend our discussion of function. We will discuss another aspect of function called recursion, and then we will discuss types of variables on the basis of their scope and accessibility. That is, we will discuss about local variables and global variables. So let's start our today's program. This example on the computer screen uses a user-defined function. In this example, we have declared a function with the name fact. Return type of the function is int, and the function is declared with one integer argument. The function is aimed to implement the logic of computing factorial of any number passed to it and then return result in the form of integer. You see in the definition of the function that the function is passed a value of integer type. Then inside the body of function we have declared a function f to hold the result. How the function will work? When the program is executed, first program will ask the user to enter any number. Scanf will take input for variable num. Then we call fact function with num variable. Function will be called with the value of num. Suppose the value of num is 3. Then fact function will be called with the value 3. Thus the value of x will become 3. You should remember that factorial of a number is the product of all digits up to that number. Factorial of 3 will be 1 multiplied by 2 multiplied by 3. Factorial of 4 will be 1 multiplied by 2 multiplied by 3 multiplied by 4. Factorial of 5 will be 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So this logic is basically implemented in the body of fact function. Here in the body of the function we have used a loop to calculate factorial of the number. We assumed that the value of x is 3. Thus first time loop will be executed such as I equals to 1, I less than equals to 3, yes, condition is true, control will come inside the body of loop. Here only a single statement is following the loop statement. That's why we did not use parentheses. That is why we do not use braces with the body of loop. So first time the value of I is 1, the value of f is also 1, so 1 multiplied by 1. In this cycle, the value of f will become 1. Then the value of I will be incremented by 1. New value of I will become 2. 2 is less than equals to 3. Yes, condition is true. So f multiplied by I, the value of f is 1, the value of I is 2. 1 multiplied by 2, so new value of f will become 2. Then loop cycle will be repeated, I plus plus, new value of I will become 3. 3 is less than equals to 3. Yes, condition is true. Therefore 2 multiplied by 3, so new value of f will become 6. Then I plus plus 4, 4 less than equals to 3, condition is false. Therefore control will jump to the statement following the loop body, and that statement is return f, and the value hold in f is 6. Thus the function will return the value 6, and the result returned by the fact function will be assigned here to the variable f. Thus we display on the computer screen printf factorial is f, that is 6 will be displayed. Let's exercise this example on the computer. This is our example number 1. We have declared a variable f inside the main function as well. This is variable num, and this is scanf to take value for the variable num. Then the function fact is called with the value of num. This is the body of fact. Inside the body we have declared another variable f, not necessary to f, we may declare it with another name. Suppose I declare it with r. Let's compile the program. Compilation report says there is no error. Execute the program. Enter any number. I enter 3. So factorial of 3 is 6. Re-execute it. Suppose we enter 4. Factorial of 4 is 24. Again execute it. We enter 6. Factorial of 6 is 720. I just want to explain you that we are calling a function with an integer value. Function calculates factorial of that value and then returns the result. Now we can perform this function with another method as well. Recursion. What is recursion? Is we studied earlier that a function can be called from any other function, and a function can be called as many times as required. You should also remember that a function can call itself as well, but this mechanism should be implemented in such a manner so that this calling process should ultimately terminate. Because if a function call itself again and again indefinitely, the process will continue infinitely, and therefore our program will never be terminated. Recursion is a mechanism in which a function call itself repeatedly but in controlled manner. It is defined as a function is called recursive function if a statement within the body of a function calls the same function. Recursion is the process of defining something inside in terms of itself. Recursion is the process of defining something in terms of itself. It means we implement the logic of a function in such a manner so that the function performs its functionality by repeatedly calling itself. Let's study this concept through an example. This is the same example of calculating factorial of a number, but here in this example, factorial of the number is calculated by using recursion instead of using loop. Look at the example on the computer screen. We have declared the function fact with one integer argument. Return type of the function is int. This is same as we studied earlier. Look at the body of the fact function. The definition of the fact function is such that the fact function will be called with an integer value. Then inside the body, f is initialized to the value 1. If the value passed to the function is 1, suppose we pass the value 1 initially to the function fact, then the function will simply return the value 1 as factorial of 1 is 1. Else, if we pass any other value to the function, then the else block inside the body of fact will be executed, and inside the body of fact there is a statement x multiplied by fact x minus 1. You should carefully observe that here the function fact is called with x minus 1 from inside the body of fact. So this process will continue until the value of x becomes 1. Let's study an example. Suppose we pass the value 5 to the function fact. The value of x will become 5. Control will come inside the body of fact. First time, if x equals to 1, condition will turn out false. Control will come inside the body of else, and here the statement x, that is 5, multiplied by fact x minus 1. You see in the diagram that 5 is the current value of x, and fact x minus 1 is the value of x is 5, so x minus 1 is 4. So the function will be called again from here with the value 4, and this statement f multiplied by fact 4 will be pushed on stack. So the fact function is called again with the value 4. Now x equals to 1, no, condition is false. Control will come inside the body of else block. So here now the current value of x is 4, as you see in the diagram, that now the statement will appear as 4 multiplied by the result of fact x minus 1, that is 3. So again fact function will be called from here, and this statement will remain pending. Again fact function is called with the value 3. X equals to 1, no, condition is false. Else block gets executed. The value of x is 3 this time. 3 multiplied by fact x minus 1, 2. So here in the diagram it is shown that now 3 multiplied by again function called fact 2. This statement will again be put over the stack, and thus the fact function is called again with the value 2. Now the value of x becomes 2 if x equals to 1, no, condition is false. Inside the else block x, that is 2, multiplied it by fact with the value x minus 1, which is 1 this time, is called again. So now fact function is called with the value 1, and this statement is pushed on the stack and the function will be called with the value 1. This time the value of x is 1, control will come inside the body. If x equals to 1, yes, condition will turn out true this time. Therefore, the function called with the value 1 will return 1, and that is shown in the diagram, that fact 1 will return 1. Now the result returned by 1 will be put in this expression, and fact 1 has returned 1. Now 1 multiplied by 2 will return 2. Now this result returned by the 2 multiplied by fact 1 will be put in this expression, and this time 3 multiplied by 2. This sub result return will be put in this expression, and fact 3 has returned 6. That's why 6 is being put in this sub expression. Now 6 multiplied by 4 will return 24, and fact 4 has returned 24. That's why now 5 multiplied by 24, this expression is evaluated, and the final result returned is 120, and 20 will be stored in f, and return f statement will return the final result of the function, and that result return will be assigned to the variable f. Then printf function will display the result on the computer screen. Let's exercise this example on the computer. You see, this is the same fact function. Let's execute it. You should observe one very important point in this example, that we have used CLR function before the variable's declaration, and compiler reports an error. It is because in language C, variable declaration should be the first statement inside the body of a function. Enter any number, we enter 5, and the result return is 120. Let's see the sub results returned by the function. You see that first time 2 multiplied by fact 1 return 2, then that 2 is put in the expression. The next result return is 6 is 3 multiplied by fact 2, and then 4 multiplied by fact 3 return 24. That's why the final result factorial of 4 is returned is 24. So dear students, this was about recursion. You should just remember that recursion is a mechanism in which a function calls itself repeatedly in control manner in order to perform its functionality. Now let's study types of variables on the basis of their scope. What is scope of variable? Scope of variable means the boundaries for accessing a variable. On the basis of scope of variable, there are two types of variables that are used in language C. They are local variable and global variable. What is local variable? The variable declared inside any block is called local variable. These variables remain alive and accessible as for as the control remains in the specified block. It means that when control enter any block, the local variable defined inside that block are created, and until control remains inside the body of that block, these variables remain in the memory of the computer. When control returns from that specific block, these variables are no more accessible and thus they are removed from the computer memory. Once the control returned from that block, these variables are removed from memory. Let's study an example of the local variables. In this example, we have used a user-defined function with the name 8. The function is declared with two float arguments a and b. The function will compute addition of the two values a and b and then will display the result from inside. The function returns no value. That's why we have declared the function with return type void. When the program is executed, first user will be asked to enter any two values. You should notice that we have declared two variables x and y inside the body of man. Now, these variables declared inside the body of man, that is x and y, they are the local variables of function man. Similarly, the variables a and b are declared with the function 8. These are local variables of function 8. These variables a and b are not accessible inside function man. Similarly, the variables x and y declared inside function main are not accessible inside function 8. When we call the function with the two values, function will compute addition of these values and will display the result. Let's exercise this example on the computer screen. We execute the program. Now, this time there is no error in the program because main function is using those variables which are declared inside function main, and 8 function is using variables that are declared inside function 8. Therefore, there will be no problem and program will be successfully executed. Enter any two values. Suppose I enter 3.5 for A and then 2.5 for B. The result return is 6.0 for the values passed at runtime and 5.7 for the constant values specified inside in the program. Now let's try to execute the variables x and y inside function 8. As we know that x and y variables are declared inside function man. So let's see, are these variables accessible inside function 8? When we compile the program, compiler reports two errors. And what are the errors? Compiler says that undefined symbol x inside function 8 and undefined symbol y inside function 8. Though we have declared variables x and y, but these variables have been declared inside function man. They are not accessible outside the body of main function. That's why these variables are called local variables of function man. Similarly, if we try to access the variables a and b declared inside the body of function 8, if we try to access these variables inside a and b, again compiler will report an error, and the error is that undefined symbol a and b. Though we have declared the variables a and b, but these variables are declared with function 8. Therefore, these variables are not accessible outside the function 8. So it concludes that local variables are accessible only inside that block in which these variables are declared, and lifetime of the execution of the block in which they are declared. It means that local variables remain in the memory of the computer until control remains inside the body of that block in which these variables are declared. In the example we studied, when 8 function is called, local variables a and b get created. When control returns from the body of 8 function, these variables are removed from memory. When again 8 function is called, then the variable inside the body of 8 function are created again. When control comes back, then those variables are removed. This was about local variables. Global variables. The variables declared in the prototype are called global variable. They are accessible to all functions of the program. They are equally accessible to all functions in the program. Any function can access and modify the value of the global variable. These variables are shared by all functions. They remain alive and accessible as far as the program is running. Let's study an example. In this example, we have declared 2 user-defined functions, add and subtract, with no parameters, and you see that here we have declared 3 variables a, b and c of integer data type. These variables are declared before main. That's why these variables are called global variables. You will observe through this example that these variables a, b and c are accessible to all the function of this program. That is, they are accessible inside main, they are accessible inside subtract function, they are accessible inside add function. When the program is executed, it will ask to enter values for a and b. We will specify value for a and b. Then add function is called with no parameters. Inside the add function, we are computing the addition of these variables a plus b, and the result will be assigned to the variable c. Now you should carefully observe in this example that there is no variable a, b and c declared inside the body of 8, but even then we are accessing these variables inside 8 function. Similarly, when control return, I display result held in variable c, though there is no variable c inside main function. Again, we are calling subtract function. Subtract function will be called, and this function will perform subtraction of the variables a and b. Result will be assigned to the variable c. Again, you should observe that here in subtract function there are no variables a, b and c, but even then we are able to access these variables because they are global variables. Inside subtract function, the result will be displayed. When control returns to the main function, inside the main function, again we are displayed the result held in the variable c. Now, this example shows that the variables declared before main function are called global variables. You see that these variables are accessible to all functions as we are accessing the variables a, b and c inside main. We are accessing the same variables inside add. We are accessing the same variables inside subtract. And as I told earlier, that the change reflected by any function will be reflected to all functions. Therefore, you see that in add function, the values of the 2 variables a and b is added. Thus, the value of variable c becomes the addition of a plus b, and the same value of c is accessible inside the main function. In subtract function, A minus B is computed, inside subtract, the result in C displayed is a subtraction of A minus B. Similarly, the same result in C is accessible inside main function. Let's exercise this example through the computer screen. Enter value for A and B. I enter 4 for A and 10 for B. Now you see that the result 14 is displayed from inside 8 function, then the result C equals to 14 is displayed from main function. Then result minus 6 is displayed from inside subtract function, and the result minus 6 is displayed from inside the main function. Let's execute the program again. I call the function. Function asks to enter value for A. I enter 20 for A and 5 for B. Now you see that 25 is displayed from inside 8 function, and the same value of C is accessible inside main, and the result 25 is displayed from main function as well. Then the function is called, subtract function is called. Subtract function computes subtraction of A minus B. Result displayed from inside subtract is 15, and the same result C is accessible from inside the main function as well. Scope and accessibility of the global variables. Global variables are accessible to all functions of the program. Their scope is the entire program, and accessibility, they are accessible to all the functions of the program. Lifetime of the global variable is the lifetime of the execution of the program. When the program is terminated, then global variables are also removed from the memory. You should remember that if there is a conflict between local variable and global variable, then local variable takes precedence. For example, if there is a global variable A and if there is a global variable A and there is a local variable A as well inside the body of the function, then the local variable of the function will hide access to the global variable. So dear students, it concludes our discussion of function. Local variable of a function has precedence over global variable. It means that suppose if there is a global variable with the name A and a local variable with the name A inside the body of function, then the variable inside the body of function takes precedence over the global variable. That's why the local variable will hide access to the global variable. So dear students, it concludes our discussion of functions. In functions, we studied how to create user-defined functions, and especially in our today's program, we studied how recursion is implemented and local and global variables, and we also studied how local and global variables are accessible inside the program. It concludes our today's program. We will meet with a new topic in next program inshallah. Till then, Allah Hafiz.